Hello, this is Galia Kisieva, and I'll be presenting an activity that proves the side-side-side postulate for triangle congruence. The activity is adapted from the New Jersey Center of Teaching and Learning's website. The Kentucky Academic Standard the activity covers is HS Geometry 5. Know and apply the concepts of triangle congruence. The activity also touches upon all standards for mathematical practice, all 8 of them. The objective for the day for the activity is for the students to participate in proving the side-side-side congruence postulate. Before the activity starts, I believe it's appropriate for students to discuss what congruency means, the symbol for congruency, visual representation of two congruent triangles, the notation, and further on examples and counter examples of what congruent triangles are. And it's appropriate to mention that students should understand that congruency is not affected by any of the rigid transformations. Triangles could be flipped, rotated, and mirrored, and congruency could be preserved. A word bank is also very useful prior to the activity, especially if you have struggling students or English language learners in your classes. These are the three terms that I like to present visually before starting the activity. What is a corresponding part, included sides, and included angles. Then, as well as the side-side-side postulate, students should be familiar of what they are proving and what they're trying to prove or disprove, the definition of it, visual, and notation for the postulate. The activity uses 6 straws, a ruler, scissors, protractor, and a pencil. I usually use 2 colors of straws. I'm sorry, 3 colors of straws. So every 2 straws are the same color, since the students will be building 2 separate triangles. The activity starts with asking the students to pick 3 straws and measure sides 10, 5, 7 centimeters and cut the straws to that length with scissors. I usually conduct the activity in groups as that promotes discussion, increases engagement, and usually makes the activity flow quicker. After the students cut the straws to the corresponding lengths, they're asked to arrange the set of 3 straws into a triangle and label the triangle according to the instructions A, B, and C. That's a good place where the teacher could connect the activity to prior learning and the triangle inequality theorem and discuss why does that triangle exist. After that is done, the students are asked to sketch the triangle one that they represented with straws. So they get into the habit of sketching in geometry and using that to facilitate their problem solving. After the sketch is done, the students in a group are asked to use the protractor to measure the triangles A, B, C. These measures will be approximate, of course, but again, there is another opportunity to connect to prior learning that the sums of angles in a triangle the sum of angles in a triangle is 180 degrees and give students a point at which they can check their work. And if the sum of the 3 angles for them is much bigger or smaller, they can correct their work. The next step in the activity is very similar. The students are repeating all those steps, but with the leftover 3 straws, creating triangle 2 with the same lengths, labeling the triangle with X, Y, Z this time. So it's clear that the students are creating 2 separate triangles. They're sketching the second triangle similarly to the first one, and then using protractor to measure angles X, Y, and Z. Once that part of the activity is done and the 2 triangles are built in front of each group, the teacher should facilitate the discussion with the following questions. Do you think that triangles 1 and 2 are congruent? Why do you think they're congruent? What are the corresponding parts? Can you write the congruency statement? Is it possible to create triangle 2, so it's not congruent to triangle 1. Based on the answer to question 2, did you find a shortcut to prove that two triangles are congruent? And the culminating part is to write a conjecture based on the facts that you discovered during the lab and the activity. Now, instead of asking questions and getting answers, I really like to create a discussion in the classroom to avoid shy students being silent, or students who are doubting themselves, and really base everything on the activity, make it light, but also leading to conceptual understanding and showing how side, side, side always creates two congruent triangles regardless of orientation of the triangles. Sometimes if students are struggling of understanding, I ask them to cut out their sketches and overlap the triangles to see that they fit perfectly. And that is basically it. The goal of the activity is to gain understanding of side, side, side postulate, and then use it further in proofs, which are proving very, very difficult for students. So going through that is very helpful. Thank you so much, and I'm looking forward to your feedback.